Okay, we'll give about one more minute so that those on YouTube or those that wanted to go on YouTube can come in. Okay. Hello, everyone, here and on YouTube. My name is Jared Rice, and I'm representing, or I'm head of Pratt Futures. Pratt Futures is a student-led and run lecture series where we try and bring forth topics that a lot of the student body wants to look into, has interests in, and we try to empower voices we think should be raised and on topics that we think are relevant. So today I'm excited to bring an event titled Land, Energy, and Building Life Cycles. We are looking to reevaluate and rethink how we approach design and building from a variety of different scales and perspectives. As we'll see today, looking at various means of sustainable practices going into design and going into the initial design proposals, as well as post-occupancy evaluations, looking into different retrofit models, seeing how we can deal with the existing urban fabric, and then rethinking altogether various approaches to design. I don't want to hold on for too long. So the first speaker that we'll have is Dan Stine from Lake Flato. And he is the Director of Design Technology at Lake Flato and co-author of the forthcoming AIA Climate Action Guide for Practice. And I know there are many other things that can describe you, but I'll let you do that. And without further ado, Dan.
Awesome. Thanks, Jared. I'll go ahead and share my screen. And you said I have about 45 minutes, right? No, I'm just kidding. 15, 20 minutes. And actually, I didn't get these in my slides, but I told Jared I'd mention these, so I'm going to do it right now before I full screen my slide deck. A couple of interesting things that we're involved in has to do with prefab. So we have this concept called Porch House that we've worked with many clients where they can pick from a kit of parts, and then we develop the project into the site and occasionally have connective pieces that are custom designed. Another parallel effort that we were working on with Benson Wood and Karen Timberlake is a project called Open Home that you can see on Benson Wood's site. And then finally, this is still not a lot I can say about it, but here's a public facing blog post from Enscape of a 3D printed house that we worked on in Austin, Texas, which is getting that project, and our client is getting a lot of publicity right now in the media. So again, as Jared mentioned, I'm Dan Stine, Director of Design Technology at Lake Flato here in San Antonio, Texas. I'm a registered architect, Wisconsin registered. I've taught graduate architecture students at NDSU for 7 years, written 14 textbooks. One of them is the #1 Revit book in North America. 2 of those books are on architectural hand sketching. one of which has a sketch from the late Caesar Pelli in it. I'm a blogger. I have a blog called BIM Chapters. I also am commissioned to write blog posts for Enscape fairly regularly over the last 2 years. Presented internationally. I'm currently the chair of the IES, the Illuminating Engineering Society BIM Standards Committee. And then, as Jared mentioned, I was on a 6-person team commissioned by the AIA to write the AIA Climate Action Guide for Practice, which is forthcoming and meant to parallel the AIA framework for design excellence, where that is predominantly about projects. This is predominantly about developing a firm business architectural practice that is sustainably minded. Here's my picture of my students at NDSU, where I still teach remotely now from Texas. If you're not familiar with Lake Flato, here's a couple of highlights. We're based out of San Antonio, Texas. We have an office in Austin. We were Firm of the Year in 2004, AIA Firm of the Year. 2019 Architect magazine ranked us the #1 firm. We've won more AIA Coat Awards than any other firm in the US. And we've been an AIA 2030 commitment signatory for 10 years, the year it came out. We focus on craft, place, performance, and community. And so this fits in nicely to the concept here of the theme of the presentation on place and community and creating sustainably minded projects. We have different studios ranging from residential to higher ed learning, which is K through 12, EcoCon, and urban development. And we've worked on projects all over the country. About half of our work is national these days, with quite a bit of work in the Texas area. Here's a few samples of the AIA Coat Top 10 Awards, various projects. We won 2 in 2020. One was for the Austin Central Library. Another one was for the Marine Research Center in southern Mississippi on the Gulf. It's a resilience-based project. As I mentioned, we've been a signatory of the AIA 2030 commitment for 10 years, and here the orange bars, higher is better. The dashed line is the goal for our current year, for example. So we're doing slightly better than the national average based on the AIA 2030 firms that report, and what the AIA is sharing as the aggregate numbers. The recent AIA 2030 by the numbers has a featured page on Lake Flato in that document, where we talk about what other firms can do to become members of the AIA 2030 commitment. And then I'm going to talk quite a bit about operational and embodied carbon and post-occupancy evaluation. But first, I just want to share a little bit of the organization of the firm when it comes to sustainability. All the things that I mentioned didn't happen by accident. They're all carefully thought out and managed, and there's quite a bit of follow through on our goals and commitments that we make within our project. So we have this hierarchy of our director of building performance, Heather Holdridge, and we have a building performance coordinator, Kate Sector. Kate meets with one designated studio champion for each studio, and then each project has a designated sustainability or building performance champion. So there's lots of opportunity to disseminate information, to ask questions, share information. We have a public-facing and currently updating our sustainability action plan. We call it Design Performance Action Plan. Has 3 main categories: practice, people, and planet. The next couple slides are just some highlights from different sections within this document. So objective 2A, integrate indoor environmental quality goals into every project. So we'll do things like in the right here, you'll see Rhino and Climate Studio to do annual daylight analysis. In the lower left here, the quality views, this started as a Grasshopper script, and we now have it developed as a custom Revit add-in, not Dynamo, but actual add-in on the ribbon that anybody in the office can run on any Revit floor plan, for example. Operational carbon, so to achieve 100% net zero energy by 2030 and regenerative energy by 2050, we predominantly use as a democratized option to do early energy modeling Revit and Insight. So Insight, Revit's able to automatically create an energy analysis model, and we can push that out to the cloud and do DOE 2.2 and Energy Plus analysis. And then also there's an add-in to Revit where Autodesk worked with NRail, and we can get similar results to using the PV Watts tool in Revit within 15 minutes from start to finish. For embodied carbon analysis, we use Tally, which recently it was created by Karen Timberlake, and they recently gifted it to Building Transparency. So from what I understand, EC3 and Tally will merge at some point. But Tally is an add-in for Revit that allows us to analyze embodied carbon. So more on all of that in a little bit. Recently, I worked on a white paper with one of our MEP consultants where we're looking at the point of diminishing returns on wall and roof insulation. And then we decided to expand that given that our consultant and us, we work in different locations around the country. So we took the same project and put it in multiple locations. And one of those locations, Climate Zone 7, I forgot to mention earlier, if you saw my bike in the winter garb, I used to live in Duluth, Minnesota, which is Climate Zone 7, and biked year round and up to 20 below and 500-foot elevation difference between work and home. And then in addition to Insight, so I did use Insight to do this analysis to get KBTU per square foot per year for the predictive EUI. Insight also has access to the national utility data for gas and electric. So you can also see the cost per square foot per year, which is interesting as it doesn't directly correlate to the EUI based on the different rates at which electricity is available in, say, Miami versus another place that might have hydroelectric at offering electricity at a lower cost. A couple of real quick slides here on the just when I was talking to Jared about this presentation, there's the mention of BIM a few times, and so we have this process of taking a Revit model, whether it's just massing or Revit elements, and creating the energy analysis model within Revit that you can visually validate. And you can see on the right here that the what was a monolithic floor and roof that extended to be a canopy and a balcony became shade surfaces in the EAM. Similarly, in this vertical example, where you might have a tilt-up precast panel wall system that goes from the top of footing to 2 feet above the roof to be a parapet, that got split up into 3 separate surfaces, analytical surfaces, without having to do that manually. So the area of the wall is properly narrowed down to the space adjacent to the exterior and the occupied space. The roof, for example, becomes a shade, or the parapet becomes a shade surface. Insight has the ability to export to the AI DDX. Here's an example of an intermediate option to review and edit the data before you push it out to AIA's 2030 commitment website, which is where the official reporting is. If you're not familiar with the AIA 2030 commitment, or basically firms who sign on to this are essentially obligating themselves to report the predictive EUI of their entire portfolio of projects. So next, I want to focus on operational carbon. We'll talk about embodied carbon after we talk about operational carbon. So again, the 2030 challenge, the bigger picture of it, apart from the AIA 2030 commitment, is the goal of reducing carbon down to net zero by 2030. We have a strategy here for how we do energy analysis in the firm. And we typically try to do it early on, where we're, the biggest mistakes in a project, if you will, are made at the beginning of the project. Meaning that if you don't take a look at some siting of the project and passive strategies, you're losing a lot of opportunity to reduce the peak loads for what has to be taken care of by active or even on-site or off-site renewables. We want to try and reduce those peak loads as much as possible. And so we do that by doing massing studies and looking at different configurations of a project: 1-story, 2-story, square, rectangular, L-shaped, things like that. And then as the project develops, we'll continue to do more energy modeling all the way up until we get into construction documents or late design development. We'll have the mechanical engineer get involved and do some more advanced energy modeling, which is again focusing on operational carbon using tools like train trace and IES. And then I have a case study I'll show you in a little bit on, we do quite a bit of post-occupancy evaluation. Also in the middle here, you'll see PV analysis using, again, this very simple tool that's available to us within the Revit environment. I always argue that there's no reason, even if it's not currently part of the project, to do a PV study and then share that with our client. The AIA Code of Ethics basically says that architects are required to help educate clients on environmental topics. And so this is a great opportunity to say, if we had this certain amount of PV on this certain roof that's oriented in a good direction, we could offset our predictive EUI by this much. And if it takes 15 minutes, like I said, why wouldn't you do it on every project just to see what the potential is? And when we talk about siting a project, one of the first things we do is look at microclimate data. We have a Grasshopper script in Rhino that pulls all the graphics that you see here from a weather file. And then we develop this graphic on the right as well, related to each project. We're in the process of updating our Revit start screen that will have a lot more of this microclimate data and project building performance goals embedded in this screen that every person on the project, even people who jump on for the last 2 weeks, will have the opportunity to understand the project. We have these integrated design workshops that we do on most projects where we get everybody together, mechanical engineers, consultants, stakeholders, people who often aren't involved until later in the project, to develop these shared goals and maybe not the strategies at this time, but to just all get on the same page about what we're trying to do. There's various certifications that we do depending on the project and the client. There's various strategies. Again, like I mentioned, there's passive strategies in terms of shading, orientation, and then there's even occupant this last tenant option, how basically the plug loads and the way the buildings will be used. There's these different steps that allow us to get to net zero. So here's an example of a project. It's one of my favorite Lake Flato projects. It's called Confluence Park. It's here in San Antonio. And we've done quite a bit of post-occupancy evaluation with sensors. I'm kind of a sensor nerd myself. Alexa, ask Sense how much power I'm using.
Your home is using 989 watts.
So 989 watts. Both my wife and I are working from home, work from home. We're actually remodeling our office right now, so we're still extending our work from home. So here's a few images of the structure and the building. It's on a river here in San Antonio. And so you can see the graph here showing the baseline, the energy consumed, our predictive EUI, what the EUI is after PV. And then there's a breakdown of the metering that's done by circuit, so we can tell what each item in the building is doing in terms of energy use. We were just recently out there. That's me on the left, and one of the project architects in the middle, and then our sustainability coordinator, Kate, on the right, and on the far right. The monitoring system was offline, and we had to go out there and do some troubleshooting. So now I'm going to go through some embodied carbon examples and discussion. So here's a workflow that we have for embodied carbon. This you'll be able to go back and look at the video and pause this, but we have a couple of different scenarios in which we do this embodied carbon analysis. We have a really great embodied carbon report on our website right now that was just published with some case studies, one of the projects that I'm going to show, plus several others. But we'll either do design options, which is across the top, or the whole building across the bottom. And similar to operational carbon, there's various strategies that we can layer to get to zero embodied carbon. Some of them involve reusing buildings. That's a great first place to start, is not building a new building if possible. Replacing carbon intensive materials like concrete and steel, using sequestering with bio-based materials, and then low carbon interiors. If you're not familiar with MSR Design in Minneapolis, they recently published a report on embodied carbon for casework and countertops, which is really great. And then there's the transportation. So here's a case study of a project. It's the first boutique mass timber hotel in North America, and it's in Austin, Texas. You can see some really beautiful pictures. It's a completed project. I love this picture where we built the building around several trees, and really around and over and under. There's a lot of prefab and modular pieces that were brought in. Here on the site, you can see some of these big trees that are being saved and some modular pieces being dropped in. So I did the embodied carbon analysis on this project using Tally. We had a really special flooring system. So if there's not a EPD for a material, it's a little tricky to develop it properly. This project actually, well, I'll talk about that material in a minute, but the traditional concrete structure, is the baseline, and replacing all of that with mass timber reduced the global warming potential, if you include biogenic, by 52%. If you exclude it, it's 13%. We like to share both of those numbers. We can talk more about that later if people have questions. The flooring here was unique. It's called a DLT, or dull laminated system. So it doesn't have any nails in it or glue. So that significantly reduces the global warming potential of what already is better than concrete or steel. So NLT, nail laminated timber, and DLT is dull laminated timber. And then these are my last two slides. Just reflecting on our own project, our office, this 3-story building that we own in San Antonio, Texas, which is about a block and a half from the Alamo, which is basically downtown San Antonio. And there's a blog post. You can see the link across the bottom if you want to check that out and learn about how we're working towards achieving net zero carbon for our own project, including offsite renewables. So that's it for me.
Thank you so much. Towards the end, we really started getting into with the DLT, talking about various different construction methods, and we'll get more into that. But one of the things from the beginning of the presentation and one of the last few slides was showing different ideas about retrofitting and renovations, which is a very pressing topic because we obviously just saw very intense and very high level usage of technology to design and preliminary design as well as post occupancy. But following that up, there's a ton of buildings within our urban fabric. And to talk a bit more about how we can start to address these, Dom is about to show us his presentation. He's from BlocPower. He's the chief engineer, a member of the NYC Urban Green Council committee, as well as the building electrification of NYSERDA. And without further ado, Dom, please take it away.
Thank you, Jared. And thank you everyone for allowing me to present tonight. So I hope you see my screen okay. I still have a few things on it, but yeah, so thank you again for this opportunity. And just a little bit about my career. I'm an energy engineer, and I've been trying to make buildings more efficient for the past 30 years. Today I'm going to present the topic of the presentation today is very vast, right? From land, energy, and building cycles. And my focus today will be really in around the buildings, existing buildings, and energy and energy waste as we see them in buildings today. Okay, so a little bit about the company I work with. BlocPower. The company is about 7 years old, and we consider ourselves as a clean tech company. Our founders, Donnell Baird and Keith Kinch, are still with us, very active, and they are respectively our CEO and general manager. What we are focusing on as a company is really looking at the residential, both small home, individual homes and multifamily buildings, as well as small commercial buildings. So small to medium-sized buildings is our focus. We are not a large company. We double our staff from 2 years ago, from 24 to more than double. We are about 58 now. So we didn't want necessarily to compete up front with very large companies or taking care of much larger commercial buildings and high rises. So we have our niche, and I think we are doing a good job here to try to make buildings better. So what we use, the technology we use, as you know, when it comes to retrofit a building, there are many stakeholders, there are many parties involved. not only the different trades, there's MEP firm, there's a financing, there's all this, right? And it is generally a very complex undertaking for a building owner. And remember, we are working with residential, multifamily buildings, affordable housing, owners of affordable homes and buildings, where the complexity of putting together a deal is sometimes too complex, right? It's a little bit too complex. So we try to be there for those clients, for those building owners, to be some kind of a one-stop shop, I would say, right? Just to provide the tools that allow us to speed up and to share the information with all the trades involved, right? So, and our company, we still consider, you know, ourselves as a startup, really to help us bringing more investors in our companies. We went through the Series A investment round, which was successful in bringing over $80 million of investing money, and we're going for the Series B now. So you recognize maybe a few names that you have seen before, as the U.S. Department of Energy, Con Edison, a local New York City utility, and so on. So what is BlocPower's impact so far? Since the inception of the company, we realized over 1,000 energy efficiency projects, right? Some from replacing lighting, but also more advanced, I would say, retrofits, and some boiler replacements, for instance. And what we have been doing as a company for the past 3 years is really looking at electrification as a solution to reduce CO2 emissions, right? So this has been really our focus this past 3 years, and I'm leading this effort with a few of my colleagues. And you can see a little bit, a few numbers here, how much we help save not only CO2 emission, but also dollars on bills, right? That's also one of our focuses. Job creation is very important now. That's a scale, you know, rating system that politicians and others are really looking to increase, right? We do have signed a project with New York City's mayor's office to create 1,000 position with the electrification strategy that we have for buildings. So what is a challenge? I was fortunate to attend a webinar that was held in London. Actually, everything was remote, so it was easy for me. Just the change in time change was a minor issue, but I was fortunate to actually help putting it together and providing some insight regarding cities. Cities was at the core of the discussion and the presentation, and the fact that they are consuming 2/3 of the world's energy, right? And there were basically 3 buckets of strategies that were defined to move those cities away from fossil fuels in general, or to decarbonize those cities. And those 3 buckets were building and construction, which represent 36% of the total energy consumption, the largest. There was a city's infrastructure, and the third one was about transportation. So today I'm going to focus on buildings. I think you understand that now. I'm going to focus also on heat pump, which is a system an electric system that doesn't need any fossil fuel to operate, and that can provide heating, cooling, domestic hot water to a building, right? Through a very high efficiency system. As you certainly know, Sunday, the COP26 was launched in Glasgow, and our company was very fortunate and to kind of prep also the White House, and Donnell Baird, our CEO, was fortunate to prep Vice President Harris on heat pumps, and you will certainly hear, if you have not done so, hear about the COP26. That there's going to be a focus on heat pumps as well as electric trucks. So if it might be a heads up for you, but be on the lookout for more communications around that. That slide was put together over a year ago, and heat pumps are going to be the technology of choice for building. The $95 billion of worldwide annual sales is probably going to hit a higher figure by 2025. So how do they look like? And I'm not going to talk too much technical, although I'm very tempted as an engineer, but you probably have seen those systems either in offices or hotel rooms, right? And those they are called multi-splits, right? So they comprise of an outdoor unit here and an indoor unit here, which is also called indoor unit or head. And the fact that it's split is those systems are in two different locations, right? There's refrigerant lines and electric wiring to control each other, I would say, that ties them up. And that's for mostly residential buildings, right? Now there's a VRF, or a variable refrigerant flow, which is a little bit similar to the multi-split in terms of principle. They are larger commercial units with more terminals, more choices around the terminals. All this in the arch, I would say, right, in the arch is our indoor terminals, right? Those three larger systems go outside, right? So how it works is on a heating mode, that take the energy contained in the outdoor air, right? And through a refrigerant cycle can generate some heat within the building, right? For the space to be heated. And the system can reverse in summer, and it works like an air conditioner. So consider heat pump, if you want to have a definition, as an air conditioning that can reverse its cycle and actually heat a space during the winter. So I'm going to be now a little bit more general and talking about energy measures for an existing building. So now we'll put those measures into four categories, right? The first is the low cost, no cost, and it tells it all, right? It's a measure that is typically not too expensive. Some can be done in-house, for instance, that can generate some savings. It could be replacing a light bulb with a LED light bulb, right? Or multiple of them, right? Just to make sure that obvious holes in a building, for instance, can be caulk or caulk, yes, caulk. Or so this is the first category of measures: low cost, no cost. And then you have the energy efficiency measure. And the energy efficiency measure is, let's say, a recommendation or the installation of equipment that can generate savings in a way that we can recoup the investment after a certain number of years. For instance, you have a boiler that have a life of 15 years, right? If we want to replace a boiler with a more efficient boiler, right, we want to make sure that this more efficient boiler can generate savings so that the saving can recoup the investment in less than 15 years, right? So that is an energy efficiency measure. So the lower payback or simple payback we have on the measure, the better it is, right? Then we have capital investments. They are generally not tied directly to generating energy efficiency. That can be repointing a wall, exterior wall, brick wall, masonry wall, right? or other large investments, right? So that's the three categories. And then you have the deep energy retrofits. And a deep energy retrofit can be considered when more than 50% savings can be generated from the baseline being the existing condition to whatever measures we put or install in the building, right? So they are typically a combination of the three prior categories: low cost, energy efficiency, and capital investment, right? It's some kind of a package to get to a high performance building from a baseline that is typically not too good, right? So what type of equipment are we looking at? Well, we tackle heating, ventilation, air conditioning system. The building envelope improvement also is very important, and it's can also tie to also the building system. Lighting, other electric upgrades like motors, for instance, motors for fans, for pumps. There's a multiple large number of building systems that have now high efficiency products to help us. Controls and automation is also very important, just to make sure that we don't overheat, overcool a building. And on-site generation, such as solar panels, is one of the retrofits that we like and that we have seen on the previous presentation. So electrification, again, among all those retrofits, is one that has I would say, one of the largest impact in terms of CO2 emission reduction, right? And we are talking now about energy waste, right? So those numbers that you see on the screen is really an example for 2,000 square feet house that is located in New York State. And what we did is really to compare the natural gas boiler, what is the consumption versus the air source heat pumps. And there's many ways we can actually look into that. First is the site energy consumption, right? So how much the building owner actually pays, and how much the building consume at the site is being displayed here. And you can see that from natural gas boiler to a heat pump, the site energy can actually be reduced by a staggering 74%. But this needs to be compared, however, to the source energy. So the source energy is a little bit different. Natural gas, is being pumped somewhere, being transmitted through pipelines to a building, right? Electricity is a little bit different. Electricity is, for the most part, generated at the power plant, right? That is miles away from the building, and there's an inefficiency, a poor efficiency, I would say, in how we generate power, right? Typically in the 30–40%. And also there are losses in the distribution lines, right, in order to get to the building. So to really try to compare apples to apples, oranges to oranges, right, we're looking at source consumption between the two, the gas boiler, I would say, and the air source heat pump. And then the savings drop, I would say, to 30%, but still, this is not a couple percent. We're talking about 30% in savings in source consumption. And this is why you're going to hear more and more about heat pumps and electrification as a solution to reducing CO2 emissions. And you can see here at the last, at the bottom row, what does it mean to the CO2 emission, right? So here again, moving from one heating system to another, a fossil fuel heating system to a electric, cleaner heating system, we can reduce, 70% of the CO2 emission, which is again a huge number. Now we are talking about New York, right, where the grid, believe it or not, is relatively clean and cleaner than most other grids, right? In New York, the grid, electric grid, the power grid supplying New York buildings is over 50% green or clean, right? It means that more than 50% of the electricity is being generated by non-fossil fuel, non-polluting plants, right? So I'm talking about hydro, dams and water, as well as solar panels, also fields of solar panels at the utility level, nuclear plants as well, right? Anything that doesn't generate CO2, right, at the production of the power, right? So this number might be a little bit higher in different regions, right, of the US, right? So be aware of that as well. But still, we're not talking about a few percent, but a number that jump at you, right? 70% is significant. So I was talking about deep energy retrofit before. What we try to combine as much as we can is to combine electrification, so those heat pumps I presented earlier, with other measures. And that's why the package to come to a deep energy retrofit must include other elements or other measures. In this case, air sealing or looking at the building envelope is a great strategy. We try to air seal the building envelope, right? And in some cases, most of you are certainly living in New York, and you're probably aware of those 4- or 5-story walk-ups that are over 100 years old, brick, brick construction, red brick construction. Those walls are not insulated. This is bad, but how do we make them better, right? Well, one solution is to put a cladding insulation around, to wrap this building with insulation and a new cladding, right? So first, they look different. And secondly, they are much more efficient because the heat pumps first that don't have to be as large, right? We can reduce the size of the heat pump as we are also insulating the exterior wall, so the heat losses are being reduced, right? So it's two benefits: to size the heat pump system and cooling heating system to a lower level, and secondly, to offer the building owner, whoever pays the utility bills, to have reduced expenses and less, lower bills to pay, right? So that's a double win. It's a win-win situation here. And on top of that, as you know, bringing a new electric system will require more power. And one way to compensate, not to replace, right? Let's be very clear, to compensate for this increase in electric peak demand and consumption is to also install, along with heat pump, to install on-site generation, in this case, solar photovoltaic panels, right? That will help, with lowering the cost of electricity instead of purchasing electricity from the grid. Those panels will complement, some of the additional power needed to run the heat pump systems. So retrofit can make a huge impact. Those deep energy retrofit, assuming we can, go to 70% energy savings, which is, still it's a possibility. I've seen some buildings going this route. This is an example for a 10-unit apartment buildings, right? Multifamily building in New York. We could get rid of 6 cars, off the road. That's for one building. There's 1 million buildings in New York City, okay? So I'll let you do the math, talking about, what impact electrification associated with solar can actually do. So we do have tools to help us how we get there, right? We have some tools, and working with existing buildings, We use energy modeling software. eQuest, Energy Plus are the tools of choice that allow us to predict the savings post-construction, at least the one that we project. We try to calibrate also this software with utility bills. Again, this is existing buildings, so we have that luxury, quote unquote, to compare it to the utility bills. We also try to connect to the, talking about utility, to have a utility API, which is basically an automation to collect information about the energy consumption of the building, right? Just to connect to a website to automatically retrieve information on consumption. And now with smart meters, we can have consumption at a 5 minutes interval, 15 minutes interval. So we have precise data that help us, commission the building, and verify. MNV means measurement and verification, by the way, to verify the savings that we projected, right, and to verify the performance of the retrofit that we install in the buildings. And then we use also artificial intelligence computing. I put that on a third bullet, but typically in the order of our sequence, this module actually help us identify buildings or do the outreach to building owners. So this is one example. You recognize the downtown Manhattan, and where we are able to put this type of visualization tool for the city, for the utilities, for other clients. And what we do, we collect proprietary data. I mean, also public data. There's a system called Open Data in New York, where we have tons of information about the square footage, when the boiler was replaced. I mean, we have a ton of information that we grab, collect, massage, and to come up with a strategy, basically, to say, hey, let's work on that building block, right? And try to tackle what are the most, just to select what buildings are the most, the best candidate for electrification, for instance, and other type of retrofit. So I wanted to present that to you today. That closes my presentation, but I'm very eager to continue the conversation after our next presenter and answer your questions later on. Thank you.
Thank you so much, Dom. Wow, this is going very well. I want to thank everyone so far. And so we've talked about what goes into sustainable design and integrated practices there. Started to talk about retrofit models and how we can reevaluate the current existing fabric. And I'm excited to get to our final portion where we start to question a lot of the foundational parts or foundational systems that make up how we design and how we build. And I don't want to explain on different things. I think Felix can explain well for himself. So Felix.
Yeah, thank you, Jared. Thanks for the invitation. And thanks to my fellow speakers, because it makes my life really easy now to build on all of that fantastic information that was presented already. I'm an assistant professor at Cornell University and direct the Circular Construction Lab. I'm also a licensed architect in Germany and co-founding partner of the Office 2HS. And so the projects that I'm going to show today are a mixture of these two different offices and the lab, and of course all the people that are behind that, right? So I'm the lucky one that gets to speak about it, but I want to acknowledge all that work that is being done in the background. So I want to talk about circular construction today, but to start, just a couple of slides to understand where I'm coming from and why I personally believe that this is such an important topic. And so we're, of course, as I think everyone knows that by now, living in the Anthropocene. And the reason why is that human influence about in the 1950s overtook planetary importance. So until the 1950s and for the last 800,000 years, the climate on the planet was determined by planetary constellations. So how does the sun and the earth move around each other? And then what you can see here on the screen right now are indicators, and it doesn't really matter what we look at. It could be forest loss, tourism, dam construction, population growth. They all are eerily similar, that they start growing exponentially in the 1950s. And so that is sort of the beginning of this new epoch on the geological timescale. And you might wonder, what does that now have to do with construction? If we look at a couple more graphs, this is the resource extraction from the Earth's crust, both in total and in per capita numbers. You see a very similar curve, magenta here being building materials. And so each of us is using more and more materials. In fact, if you sum it all up, the built environment, so all buildings together over their full life cycle, are responsible for more than 50% of resource extraction, more than 50% of global solid waste production, and I believe more than 40% of global CO2 emissions. And so looking at these emissions a bit more closely, you see exactly the same curve again. Exponential growth starting in the 1950s, and what we need to do now, and this has been presented before, charts from Architecture 2030, is basically mirror this curve, right? We need to act very, very quickly, ideally 65% reduction in the next 9 years to have a chance to reach this 1.5 degree limit that the Paris Agreement, so the last COP, decided on. And in that respect, it's interesting to look at the kind of different influence that building operation or emissions from operation and emissions from the construction and the production of materials have, so operational and embodied carbon emissions, even though they are globally something about between 28 and 11%. Once you introduce that time limit, so within the next 9 years, embodied carbon emissions become much more important, right? Because the upfront emission of a new building are there on day one, versus the operational carbon emissions are emitted little by over time. And so in the next 9 years, and if I were to open a new building today, and just look at the emissions that are counting towards carbon neutrality by 2030, actually 74% of these emissions are embodied carbon emissions. And so it is very important to talk about materials, talk about the way we build buildings. And we all know that, that the least carbon emissions come from materials that are already there, right? Where we start reusing, reclaiming, salvaging, recycling these embodied carbon emissions. And so the goal is to really move from a linear economy to a circular economy, where we change the system, we change the paradigm, and we run that paradigm with regenerative sources, because no economy is really circular, right? We always need a little bit of input, but we need to make sure that these inputs are also regenerative. And so one of the definitions, there is no yet officially accepted definition of the circular economy. The one that I'm usually referring to is from 2015 by the Ellen MacArthur Foundation. And it's a restorative and regenerative system by design that aims to keep products, components, and materials at their highest utility and value at all times, and distinguishes between technical and biological cycles. And for me, really important in that definition is the word by design, right? For us, architects, engineers, designers, stakeholders of the environment, of the built environment on this call, this is really the call to action, right? We can go to the beginning of that design process and change the paradigm. We don't have to change the filter in the power plant at the end of the cycle. And so that's what we're trying to do, working on in the Circular Construction Lab, looking at the built environment in two aspects, going backwards in understanding everything that is already there, everything that is out there as a urban mine, and trying to figure out how can we reactivate all those materials for future buildings. And then moving forward, how can we design differently so that future buildings don't have to be urban mines, but can be material depots. And I'll come to that difference quickly. Just a shout out to the team. This is the current Circular Construction Lab. And so if we want to move from this linear system, I believe there are two steps, and they are very important in their difference. So the first step is to look backwards, right? As I mentioned, to understand the built environment, everything that is there already as an urban mine, which uses recycling processes, it kind of optimizes demolition. But the importance here is that a mine is still a mine, and mining is a dirty process, right? So we need energy to do that. We have byproducts. We will never reuse or recycle 100% because the mine is not made for that, right? It's not a warehouse, it's a mine. And so we still have virgin products coming in, and we still have landfilled waste going out. We're just optimizing sort of the circle in the middle. Versus the next step, which then is kind of circular construction, where we really design buildings for reuse and for disassembly, right? And so we don't need to mine anymore. We can talk about asset management. We can move particles from one, or whatever you want to call them, nutrients from one building to the next without that loss in the middle. And so even start, for example, bringing in former landfill waste through landfill mining as technology increases. And so the words here are then reuse and deconstruction, and not recycling and demolition. And I'm going to fly through 3 projects very quickly that kind of look at these different aspects that I just started with. On the one hand side, looking at new resources, alternative resources, biological resources that we so far haven't really used in the built environment. And then looking at kind of the urban mine and how we can maximize that resource. And the last project really shows how we can design differently. So this is the starting image for an exhibition that we did in 2018 in Seoul, in Korea, which is called the Mycotree, and you see mushrooms growing. What we're really interested in, though, is what happens in that bag. That's the root network, if you want to talk it in layman terms. It's actually the organism that grows in that bag, and the mushroom is the fruiting body. And so usually that is in the production of those mushrooms for as a food product, right? That is a waste product. And the analogy would be if you like throw away the tree after you ate the apple, sort of, right? You really throw that organism out. And the question for us was, how can we activate that waste product, that organic process, for the built environment, and we're not alone. There's a big community of researchers right now globally trying to activate that in different ways. Our contribution was to grow a structural a structure where that mycelium is actually used as a structural component. And so here you see pictures from that production process. A lot of testing, figuring out what is the strength, the compressive strength of this material, and how can we best use it as a structural material. And then growing these kind of bricks that are then assembled into a load-bearing structure. So this is actually holding that roof. And the important thing here is that this was only possible through kind of re-engineering the form, right? This is a kind of inverse bolt that we developed together with Philip Bloch of the Bloch Research Group from ETH Zurich. And the benefit of that geometry is that there are only compressive strengths in the system. There's no tension and no bending, because tension and bending is something that the material really can't do well. Compression is something that mycelium can do. And so knowing that, and using engineering and of course a lot of software in the background to figure out that ideal form, it was then able to build with a considerably weak material structurally, to show that there is an incredible potential in resources that we have so far not really engaged with in the way we build right now. The second project I want to show is the so-called Maverick Pavilion. It's a structure that we built for the Federal Garden Show in Germany in 2019. What you see here is a structure that is built only out of secondary life cycles. So all of the materials that were used for this pavilion already had a second, third, fourth, fifth life before them. And we divided this into 4 different categories. The shell, the roof, the facade is made out of recycled glass. The structure is reused steel. All the furniture is recycled plastic, mostly recycled plastic household waste. And then all the landscaping, the foundations is all reused and recycled mineral waste. A couple of pictures from that. This is the life cycle for this flooring. A couple images. Some of it looks very familiar, right? I mean, there's a lot of reuse going on, and it's good to point that out. The white landscaping is, for example, ground down ceramics that were destined for landfill. And here the question is more how can we figure out what's the right grinding size, what the right sieve line, to make this a water-bound surface that we can then use for an exhibition. In the end, 2.5 million people walked over this, and that worked really well. The shell is made out of recycled glass from very different sources, and you get this new aesthetic, which I personally think is another really important component of how we use our materials, how we reuse our materials, right? This the fact that we bring in a new language. So the green part here, for example, are former wine bottles, but the white is, for example, flat glass from the built environment and from windshields from cars. And so you have this kind of different languages. Important here is, for example, that you can still see the shard, right? So we only heat this material to the kind of absolute minimum to make a panel that we can use again to save on emissions, but also to create this aesthetic that you still see the broken elements. And then the last one, which was the most difficult one, is that we didn't want to use recycling steel. I mean, all steel by now is recycling steel, fortunately, right? But we wanted to show, is it possible to reuse steel directly? And so the resource that we had available is a former decommissioned power plant that the kind of 2 weeks after we took our steel components out of there, was demolished. And so the little steel that we used for this pavilion was basically rescued from this operation. But now we had the problem, we had no idea what that steel was that we took out of there, when it was produced, where it was produced, what type of steel it is. And of course, it's impossible to get a building permit with that little information. And so a lot of testing needed to be done to, in the end, prove that this is standard construction steel, which then meant that it was very easy to apply that and calculate with it and get building permits for that. Again, however, from the design perspective, that of course drove the whole design process, right? We had different diameters, different lengths, kind of potpourri of different elements. And so our task was now to develop a structure that supports this roof out of these elements. And so this kind of tree structure again emerged as one of the solutions that allowed us to do that. And so in the end, you see that pavilion glowing in the night. And then the last project I want to show is the Urban Mining and Recycling Unit, as a project that we built together with the Office of Werner Sobeck, 2018 in Switzerland. And the unit that you're actually looking at is the one that has this copper frame in the very middle of the picture, and is a unit of the so-called Nest, which is an experimental unit or an experimental building in Dübendorf, where research is allowed to be tested in full scale. It's a very exciting experiment. And so you're able to kind of push your module into this sort of overscaled bookshelf. And so our task was, can we design a building where all of the resources that we put into the building can be reused, recycled at the end of that unit's life? And we had this kind of benefit of it being a sort of academic research project, that we actually could try to achieve 100%, which in a normal built environment, you'd always compromise at some point, right? And we tried to, how far can we push that question to actually close all these loops? And so here you see how this looks like on the inside now. It's a student housing unit for PhD students of that institute. And it's built for disassembly, of course. The main design driver. So on the right side, you can see this kind of disassembly plan, which materials go where, how are they connected. But it's also produced in modules. And so on the left side of the screen, you see the construction site with these two cranes that just lift in modules. And so we actually had a one-day construction site because that was all fully prefabricated, which is something the client was quite happy about. And so a couple of the innovations in there, one of the questions was, can we build a project, can we build a mortar-free brick wall where we can directly reuse stones without having to kind of chisel away mortar? And so that developed this kind of new, not really new, but specially produced format for this unit, which is a brick with a tongue and groove system and these holes in it, which were then put on a metal rake. And basically at the top and the bottom, you had a screw, a nut and bolt. And so you were able to kind of pre-stress this whole unit to then make it a kind of component that works structurally. And the stones themselves were produced out of mineral demolition waste by a kind of small company in the Netherlands called Stone Cycling. And they take 70 to 90% of all of their stones are made out of different mineral demolition waste, and then marketed in names like salami or nougat or wasabi or aubergine, kind of from the left to the right here. The other question was, can we build, for example, bathrooms, any like wet rooms without any silicone, chemical adhesives, anything that kind of speaks against that academic goal of taking the whole thing apart and sorting it into pure material cycles afterwards. And so glues, of course, were forbidden. What you see here, the bathrooms are in the end only using dry gasket sealants that are kind of pressed on with a couple screws that are reversible. On the left side, solved in a kind of glass unit, and on the right with a HDPE, so high density polyethylene panels. And if you look at those closer, you again see this kind of this aesthetic of the urban mine exemplified as a new bathroom tile. So this is the glass, and that's the plastic element. But as I mentioned, we very quickly hit kind of roadblocks. One of them was we did not find a single faucet on the market that was fulfilling our goal. All the standard faucets are, for example, press fit out of 3 different materials. There's a copper unit in there. There's a movable part out of plastic that controls water flow. And then there's some kind of casing out of different materials. And they're usually combined in ways that are very, very hard to separate. And so we didn't find a faucet that would be circular, right? And so we had the chance in the end to then 3D print our own faucets out of stainless steel, where all the moving parts are printed in the same process. So everything is in there is stainless steel, which is of course possible in such a project, maybe not in all projects. Another interesting conversation that came out of this project was what is the question of ownership? So here you see a carpet tile, and the company developed this product as a fully circular, 100% recyclable product. And with that development, the question came, but why do we now hand this out? Why do we give this to our clients? Because the client might just throw it away, and all that development was for nothing, right? And so they shifted their business model to a leasing system. And so you now only lease that carpet for 8 years. And after 8 years, you return this resource to the company, and the company knows exactly what is in there. They've been the ones producing it. They know how to separate this. And so they, in that system, then become also independent of volatile resource markets. We've documented all of this. We have a kind of offline material database. We have also an online one, which I think is more important. This is a kind of material passport for that building, with information about which material is where, in what sizes, in what dimensions, and how are the connection details. And so once we start taking this unit apart, we know exactly in advance what is where and how can we introduce these resources into other buildings, right? We can start planning long before the demolition or the deconstruction of that structure begins. And that's the last kind of component of that lecture. A couple of the ideas that we're working on in the circular construction lab. One of the questions is, how do we know what is in existing buildings? So we're right now working on salvage and deconstruction survey toolkits, both kind of in a more Excel sheet based scenario, and also using LiDAR scanning tools and other new tech developments. And actually we're combining these now to run algorithms to kind of create these kind of summary sheets for clients, where you know what is the embodied carbon value of your existing building, what's the material tonnage, what's the material intensity. Also, we're working similar to what Don was talking about, the kind of what does it actually mean? What are these abstract numbers in terms of embodied carbon, for example? So we're looking here at one building being the equivalent of 3 acres of deforested land here in the Finger Lakes region, or the fact that you could drive 16.5 times around the equator with a standard car, with the embodied carbon value of this one building. And then the last project, because it is this kind of connection to BlocPower, we're working here in Ithaca now on an electrification project. The city of Ithaca has won a grant to electrify 1,600 buildings in the next 5 years. And we're fortunate enough to advise the city on the question which buildings could be the best case studies, where do we want to start? Because of the fact that we developed a process together with the Environmental Systems Lab to model all the residential buildings of Ithaca based on publicly available data, so GIS inputs, Google Street View for the wall-to-window ratios, LiDAR scans for the kind of roof geometry, which then leads to a mapping tool that can, and I think this is the real benefit of that tool, can both calculate the operational energy and the operational carbon emissions coming from that building, but also the embodied carbon values of that building. And so there's a kind of tool, online tool that allows you to kind of zoom into your building and look at those numbers. But it also allows us to now start running scenario calculations and trade-off scenarios. So what if we now exchange all windows or all insulation materials of a specific typology between 1912 and 1940 and electrify the building in the process? What is the urban saving potential of a step like that? But also, what is the material input and effect of a scenario like that? How much carbon emissions, for example, do we need to emit to produce all that new insulation material? And what's the trade-off? When does this pay off? In which scenarios does this pay off? And so I think that's going to be a really interesting conversation moving forward. Couple of resources, also the recent books that talk about these 3 different topics that I talked about. And I'm really looking forward to that conversation. Thank you.
Wow, thank you to all 3 presenters. Here, let me remove the spotlight so we can see everyone. Yeah, thank you to everyone. That was 3 fantastic presentations. I just couldn't stop smiling the whole time. But I want to, before I go into some questions that I got beforehand from various students, I wanted to ensure that the audience knows everyone's allowed to ask a question. If we see a question in the chat, we'll go straight to your question. You can either raise your hand and I'll just call on you and see if you want to see your question, or you can type your question in the chat. But to get us started, so one question was, what systemic policies or standards most inhibit what each of you do and or strive to do? Also, what are some alternative proposals that you think could afford and promote a more sustainable ways of design?
Okay, so we're talking about policy in general, right? I mean, at the highest level. I mean, I want to make sure that I'm going to try to respond to the question. I think to be more sustainable, I think the politics, cities, utilities, I would say all the industry needs to be talking about the same language here. This was not the case even 5-10 years ago. There's a clear movement towards making our environment and the buildings we live in more cleaner and healthier, and so there's a lot of things going on right now. I mentioned about the COP26. we'll see what's going to happen and what is going to trickle out of that, of the directions from the White House, right, and the world, right, literally, right. But I think through, I would say, regulations, I think standards, I think for new construction, which is not my forte. I mean, I think I was clear with my presentation, but there are clear standards to avoid the use of fossil fuels, right, in new construction in many states now and many cities and so on. So that's one step towards the solution, with a big S, right, a large S, right, the solution, right. And some regulations, we see utilities having, bans on natural gas, or not to be able to connect new natural gas, to have new natural gas connections. So, that's my piece of the response. I mean, it's there's a lot more to be said. I don't know if my colleagues will have another view or to add to that, but I wanted to jump in and try to answer.
Felix, you want to go next?
Sure. I was going to give you the floor, but I think for reuse and recycling, actually mostly for reuse, the biggest challenge, or one of the biggest challenges that I see, is to how do we meet demand and supply? Because we have a lot of supply. Actually, right now, most of the kind of reuse centers are overrun. They close because they can't accept any donations anymore. We have a limited demand, but the most difficult is how do we match those, right? Because meaningful reuse would be one where we don't necessarily have years of storage in between, but we can somehow move products or elements or components from one side to the next. The problem is, if for that to happen, we would need a year, 1.5 years in advance. We would need very detailed knowledge about which products will come out of a building, so that we can start designing with those products. We can start getting building permits, the permitting process, etc., with that information. And so, to come back to the question, one of the requirements that would really support that is a detailed material inventory, being material passports or building passports that could be required. Actually, the European Union is starting to enforce those now, make those mandatory for all new construction, which still doesn't answer the question, what is in the existing building, but at least it kind of starts providing information moving forward. Required in terms of what is already there, something that is very interesting in the US is the movement towards deconstruction ordinances. So kind of the mandatory deconstruction over a demolition, which simply starts saving material in a way that it can be reused, right? And the interesting thing here is that there is a lot of very valuable material in buildings. If you are taking the time to deconstruct those and to actually take them out in a usable way. And that usually doesn't happen because of time crunch, because of financial questions. But here again, policy can make a big difference and kind of channel between demand and supply.
Yeah, the only thing I have to add is the link that I added to the chat kind of adds to what Dom mentioned about the COP26. Lake Flato is among 60 firms and organizations that signed this communique put together by Architecture 2030, and it included many firms and the AIA and REBA urging global leaders to act and enact policies that will reduce CO2 emissions.
Thank you. Those are, I'm going to be doing a lot of research into those different things after this. Chris, I saw you had a question. Chris? You want me to read it, or you can read it?
No, I got it. I thought I was gonna have to get the vacuums running, but it's okay. Okay. My question is for you guys, what are your thoughts on like greenwashing in design? And over the last few years, there's kind of been this recent trend, especially within design school, to kind of slap projects with this sort of sustainable edge. And do you feel like maybe that could be helpful to get designers interested in ultimately moving towards a more holistic, sustainable design? Or do you think that this kind of leads to like a more of like a bastardization or an exploitation of these kinds of ideals? And thanks for the presentations. It was great.
Yeah, I think there's some self-regulation. I think in our industry at the like the AIA and REBA, a lot of their design competitions. I just was a juror for a design competition for a fairly prominent architecture firm on the West Coast, and more these are requiring metrics of energy use and post-occupancy data rather than just pretty pictures, right? And like the late Lance Hosey wrote in his book, if you haven't read it, it's a really great book, The Shape of Green. We'll shout out to Lance, and so high performing projects still can look great though. So that's the part of the premise of his book.
Oh, okay, yeah.
I don't have much to add to that. I think the time where we sufficiently cover sustainability with that one diagram in the left bottom corner of a poster is over. At least I really hope so. I mean, it always was sort of required, but it never really made an impact in the judging criteria. And so I think that we've moved out of that. The big question for me is, what is sustainability? I mean, that term in itself, right, is a big, you could have a whole lecture about that and still not really know what it is. And I think it is a really interesting conversation. We always try to figure out, like, how can, I don't know, 10, 15, 20 different aspects that are all sort of touching sustainability come together to a holistic understanding that then drives a building design. I think we've heard about 3 different criteria of sustainability today, or 5, but I think there are at least 10 more that are really important to mention here as well. And they all need to somehow drive this design. And so that one diagram also can't cover sustainability in its complexity anymore, right? And so I think that is something that we all need to be aware of. It starts with the site selection. It starts with the understanding who is there, what kind of people, what's the user, what's the social, cultural context that we're building, et cetera, et cetera. And then at some point, when we know that we're actually building, one of the questions could be, do we even need to build? I mean, there's this whole complexity of what is sustainability. I just wanted to kind of expand that conversation a little bit based on the question.
Yeah, I would like to add also that, just like 10, 15, 20 years ago, I used to work with Stephen Winter Associates. We did a lot of green buildings, design and so on. And the challenge was the cost of building a green building or sustainable building, whatever the definition is, right? And the cost was much higher. And I think the profession, the AIA, would try to actually reduce that cost difference to really show that with a little bit more in money, right? Or now it's almost around the same cost, right? We can actually build better, right, with a cost that is similar, right, to the old-fashioned way of building, not considering all you heard this evening, right? So I think fundamentally, you know, if we can do it now today, and for the future generations, let's continue to keep on going. I mean, that's for me. There's no alternative. You know, it's just we need to get even better at reducing. You know what Felix showed us, right, in the CO2 and from the Industrial Revolution to now. It's the graphics are there. It's not even a question anymore.
Thank you. To tie on to in talking before the presentation, or before this event, one of the things that I spoke with I think each of you about was the BIM and the technical and a lot of the ins and outs going into that. But one of the things that's still pursued through all presentations, which leads towards this question, was attention to various community, like Felix was just talking, community context, social context. So this question says, how do we ensure that technological analysis is not the sole driver of our designs, but rather a tool to use to incorporate the residents in respective communities from the beginning to end? How can these processes be combined?
I'll just add to basically tying into what I had mentioned earlier with most recently the book, the idea that good design, well, a high performing building doesn't have to be ugly, and Lake Flato's careful strategy to visit the site as early as possible in the design process, to get together with all the stakeholders early on. So not just the client, but ideally the end user and people from the community, and then to use those tools as tools to inform design, but not necessarily dictate design.
Yeah, I think, you know, the building occupant, the tenants, owners have a lot to do to continue the fight, if we can call it a fight. But their contribution in terms of how they are educated, in terms of what's going on on this planet, their awareness about energy, how to use energy systems, is a big contributor also to waste, right? So someone who knows about how to use it, the equipment smartly. I was born and raised in France, and every time I left my bedroom, I turned off the light, right? That was how I was educated, so that transpired now and totally drove my profession, but my professional life. But it's very important, and the behavioral aspect of how a building is being operated and run is an important it's an important aspect of the whole thing, right? So that's one thing. And I think also there was the question was about I would say including, I would say, the people within the community within the project. So I'm going to talk again specific to BlocPower, but there's a lot of things going on right now about lack of labor available. The labor workforce is scarce right now. We need to create it. We need to train people. And there's a clear action, at least in New York City, which I know, but I'm sure, talking to many sustainability director in many cities right now, that there's a clear need to include workforce workforce development and workforce within the projects, right? To really build, to audit, to when you are working on a project in occupied spaces, you need to schedule. The scheduling of the installation is often, you know, on the mind, right? And it requires some time. So there's in many aspects of the construction. Again, I'm seeing that more on the retrofit side, which I know best. But there's clear programs and requirements from building owners, from cities. If you have a building, you know, a city building, or, you know, and other federal buildings and local government buildings who have requirements to say you need to hire for your project people, if it's in a community, from the community, people who are looking for jobs, people who are switching, you know, gear in their education. So hopefully I'm responding right to the to the question, or try to put additional color to the answer.
If you talk about the circular economy, the most effective cycle is the smallest, right? And so and that has to do not only with the material cycle, but it has to do mostly with the locality of where this product material cycles. And so this builds directly on what Dom was just saying, that local reuse is good for the environment and it's good for the building, but it is adding exactly that missing component that has to do with social, cultural dimensions, right? It has the kind of history of that material and everything that's connected to it, but it is also helping the workforce development, because this is essentially a very local job, right? You need to deconstruct it. You need to know where to bring it. You don't want to, I mean, you're also not helping the environment if you unbuild something and then ship it across the continent. So also the local reuse, again, is on both sides, in design and construction, but even also in deconstruction. And so in many of the projects that we're now trying to do in Ithaca, that workforce development is an essential component of the whole setup of the project. We're talking 400 new jobs in the next couple of years in Ithaca, which is, and I mean, it's really great to see what that influence of this shift in thinking is. And then I think the other component, and Dan just mentioned that, I mean, the best tool is only as good as the question that you ask it, right? And so thinking about that as a designer and using those as tools and not as decision makers, I think is an essential component. Right? That's what at least we're in the architecture field, I think we aspire to know which question to ask, right? We will always find something that can maybe answer the question for us, but what is the right question? I think that is a design task, right? And so that's the important thing. I hope you as students, mostly in the audience, right, take from this, ask the critical question, right? Don't shy away from the critical question.
Thank you. That all very important points, and a good one to leave that conversation off on. During the presentation, I got a question that specifically noted towards the stone cycling. However, I think it generally applies to each person. So we often look to European models for reuse and upcycling projects, but with innovations like stone cycling, shipping and importation could potentially offset the positive effects of the upcycling and recycling. So how can we each play a role in establishing these innovations at a local scale?
I mean, I can talk a little bit about stone cycling. I mean, they're actually opening their first building next week in New York. The whole facade out of recycled mineral demolition waste, which in this case actually is Dutch mineral demolition waste that was shipped around the world. And so this answers directly to that question. That of course doesn't make much sense to now take Dutch waste and ship it over the ocean, but it makes sense in terms of that kind of lighthouse project maybe that now starts local processes, and that is the hope. Actually, the company is now coming over next week and talking to producers and trying to start up something in New York with that publicity of that building in the background. So that's one strategy. But I think we don't always have to look at Europe for examples, especially when it comes to reuse. What happens in small American communities, I think, is far more interesting. Europe is very good in recycling. But recycling comes with its own problems, and that has to do with that historically Europe is built differently, the built environment is constructed differently due to the war and other reasons. But in the US, in many areas, and of course I can't generalize this, but speaking about Ithaca, for example, most of the residential houses are constructed from lightweight timber, right? And not reinforced concrete, right? Like it would be in Europe. And so what you can do with that kind of built environment is a completely different thing, right? And the processes that you need are completely different. And so you always have to look at this very locally and figure out what can I do? How can I close that loop? So, for example, the Bay Area Demolition Working Group is an extremely good source. Everything that happens right now in the Bay Area, I think, in terms of reuse, is extremely exciting. But across the country, we have new policies that are enacted. We just had 2 weeks ago, we had the reuse conference, the National Reuse Conference, with fantastic contributions from all over the continent, and so I think that's a really valuable resource, and I think they are also recorded, and you can watch many of those contributions if you're interested in it. Just as a hint, you don't always have to look at Europe. There's a lot of good stuff happening here right now.
I don't really have anything great to share about architecture that I can think of on this topic, but just a personal experience having relocated to San Antonio just a year and a half ago, 7th largest city in the US, and every household is provided organic waste can. So organic waste, food waste, yard waste, and it's all picked up regularly and obviously recycled. But then they also, just totally different than what I experienced in Minnesota, which Minnesota is definitely doing a lot of things right, but they have this bulk pickup multiple times a year where you can put a refrigerator, a couch, a stove out on the curb. And interestingly enough, most of that disappears before the city comes along to pick it up, because there's very specific dates in neighborhoods when this happens. So there's this really interesting reuse and recycling happening at a city scale that I've been pretty impressed with.
Just as a small add-on, San Antonio, by the way, also one of the leading cities when it comes to deconstruction policies.
Yeah, I think it's also the 3rd largest, the local utility for solar power generation in the US. Second, or first or second in Texas, but up in the top 10. There's some really interesting partnerships with solar installations as sunshades and in car sales lots, for example, and local citizens who use the local power utility, which would be anybody who lives here, can purchase a PV array within this offsite um, solar installation, and it's professionally installed, professionally maintained, and both the electricity and natural gas are subtracted from your utility bill, which is different than if you just had PV on your roof. So it's optimally installed, optimally maintained, and you literally own the panels and the serial numbers on the panels, but they're not on your roof, which is just, I think, really interesting. It's part of what Lake Flato did for its offsetting operational energy for our operations in Texas.
So moving towards the last 5 minutes, I suppose I'll ask one last question. And that is, what are some exciting new technological developments that you believe could have a large impact on the future?
Yes, I can start. The mechanical engineer, I can talk a long time for this, but yeah, I mean, you're probably aware, if you're interested about the topic of decarbonization, you probably heard about carbon capture equipment. They exist at a very tiny scale, more on the demo. Demonstration, not demolition, demonstration size. So there's hope. In parallel to that, I think we need to, and manufacturers need to really need to make a big commitment to use refrigerant that are not as destructive to the atmosphere. And there's hope for, CO2 refrigerant and others, right? And as we know, all over the world, and in most countries in the world, I'm sorry, the use of refrigerants is basically everywhere, right? And it's increasing. And that's also one of the concern about heat pumps, right? That will use, refrigerant, certainly, even more. So yeah, I'm hoping on the technology side, again, more on the building systems, right? Mechanical systems, seeing more effort towards better refrigerants, and yeah, CO2 capture. I'm hoping. So and efficiency, more efficient systems, if we can. Again, reducing waste in a consumption is also very important. Yeah.
I'm going to sort of base my response on both something Dom and Felix said. So Dom had mentioned turning off lights, and there's one other thing it slipped my mind, and Felix mentioned some smaller things can have a bigger impact. And the other thing, Dom, you said occupancy behavior. So I'm a big fan of dashboards, and even this idea of sort of gamifying this. I love looking at my Sense Power app and seeing that I'm 86% more efficient than all the homes near me that use this particular real-time energy modeling. So if we can, the plug loads of buildings, and I also have a real-time water flow. It's I used to live on the world's largest freshwater lake with 10% of the Earth's fresh water in Lake Superior. And then I moved to Texas, and we have these really delicate aquifers. And so monitoring water consumption and power use in real time is, even though I've already was interested, it just made me that much more aware of it, and encouraged me to buy a 26-year HVAC system, and as I mentioned in the chat, a heat pump based clothes dryer.
Yeah.
And my family doesn't always appreciate who left the light on, but it's definitely a good thing.
Yeah, you're right. Technology and data and more data to make the decision. I think it's an excellent point.
it's not necessarily a technological development per se, but I think anything that leads to a mechanical reversible connection that is structural and can lead us to build serious structures, right? Multi-story housing that answers the requirements and the needs of the current population will have a massive impact. So if we switch from just gluing everything together to a bit more forethought, right? So really designed for adaptability, designed for deconstruction, which is something that will become probably more mandatory, hopefully as well. That will have a significant impact. If you really want to have a kind of little device, and that might sound a bit cheesy, but for reuse, the denailer or the nail kicker is actually probably the most important technological innovation, to get all those nails out again and have a reusable piece of lumber afterwards.
Thank you. Excuse me. Thank you, everyone. And that just about does it for this event. I want to thank the speakers, thank everyone who came, and anyone watching on YouTube. Again, I'm gonna post this, the transcript and all the links later, so you can find us on YouTube or you can find it on Instagram. And with that, I guess I'll allow, well, I don't want to say allow, but let you guys have any last words you wish to have.
Sure, I'll just say, you know, we talked about tools and Felix, I believe it was mentioned asking questions, and I think we need to continue to leverage tools and challenge our assumptions and validate results if we're going to move the needle on climate change. So just that's my recommendation.
Yeah, you as a student, you're the next generation, and we hope that the generations before mine and our generation actually help move the ball forward a little bit, and but definitely a big change. And you know, I'm totally sure that the next generation of architects, you know, engineers and professionals will make the goals of better sustainability and, you know, zero carbon goals being achieved, right? So I'm very hopeful for the future.
Yeah, me as well. I was going to say something very similar, that, I mean, seeing that these kind of events are student organized, right? I think that makes me really hopeful. And it doesn't matter if it's then Cornell or Pratt or any other of our fantastic universities. I think it's great. On the other side, I also don't want to kind of push all that responsibility on the next generation. I think we all have our thing to play, our part to play. But I am very hopeful that things will change, and will change much quicker the moment this new generation is taking part in the conversation.
My is it working? Can you guys hear me?
Yes.
Okay, it says I'm muted, but whatever. Thank you guys. And I guess that's it. Bye, everyone.
All right. Thank you, everyone.
Yeah,
Thanks, everyone.
thanks for having me.
Right now, I don't even know how to. My thing is completely glitched out.